term, in this session we would be talking about the hydrological cycle. Now in very simple terms, if I want to explain hydrological cycle, I can say you have water bodies from where water evaporates, formation of clouds takes place, then you have rainfall that occurs, and finally that rainfall goes back to the ocean and the cycle continues. So this is a very simple explanation for water cycle. However, in this session we would try to understand hydrological cycle in a much comprehensive manner. So let's first start with the stages of hydrological cycle. So we will be covering the complete hydrological cycle by dividing the cycle into 8 separate stages. The first stage is the evaporation. Now under evaporation, what happens is you have the sun that provides the solar energy, and that solar energy heats up the surface. So you have heating of the water body as well as the ocean body, and that leads to formation of water vapor, and that formation of water vapor and that formed water vapor, I can say, moves up or kind of evaporates. So that is the first stage under the hydrological cycle, that is evaporation process. Now when we try to understand the complete hydrological cycle, I can say we have divided our earth as atmosphere, hydrosphere and lithosphere. So atmosphere is the air, hydrosphere is the water region, and lithosphere is the land part, and the region where these three merge is the region of biosphere. So we can say water cycle is the circulation or cycling of water within the biosphere. So you have this cycling of water that takes place in all the three spheres, that is atmosphere, hydrosphere and lithosphere. Now as we talked about, evaporation is the first stage. Around 80% of the evaporation takes place from ocean bodies and 20% of the evaporation occurs from land. So that's the first stage. The next stage is transportation. Now once water is evaporated, it moves up because the evaporated form or the water vapor is lighter. Since it is lighter, it would tend to move up. So as you can see in this picture here, you have the warm air parcel that slowly and gradually rises up. When it rises up, it attains certain saturation and it starts to cool. As we have understood in the class on clouds, this rising parcel tends to accumulate moisture by condensation, and you can see the dots here which show the moisture present in the air parcel that is being cooled, and finally it moves up and forms the cloud. So this transportation process leads to formation of cloud. So when the sun's rays fall onto the surface, it leads to evaporation. That water that is being evaporated finally slowly and gradually cools down with the formation of clouds. There are numerous types of clouds that are formed, which we have discussed in the class, which we have dedicated onto the clouds and its types. Now what is the basic idea? The basic idea is, if you have a kind of any aerosol or dust particle, the water tends to condense around that particle and accumulate. It can be in form of water droplets or in form of ice crystals. In either form, it leads to formation of clouds, and these clouds are then propelled by jet streams, or I could say the wind direction, and finally reach the region where they will cause rainfall. So that is the, under transportation, clouds is the first important thing that we would understand. The second is the water vapor itself. So most of the places we would be denoting water by H2O, that's its chemical compound. So chemical composition. So 2 particles of hydrogen and 1 particle of oxygen. So you have H2O. Now water vapor, how does it helps in formation of cloud? I can say the atmospheric moisture that is present is around 10 to 50 times greater than the amount of the condensed amount of moisture that is found in the clouds. So the atmospheric moisture is again a major source that would further lead to the balancing of the water cycle, and it is assumed that around 1 kilometer thick cloud, I can say these clouds look very huge, and even if the cloud is 1 kilometer thick, it would cause only few millimeters of rainfall. So it's very important to note here that the amount of rainfall is very less in comparison to the thickness of the actual cloud. So that was the second stage. Now the third stage is sublimation and deposition. Now when we talk about the three states of matter, we generally talk about the solid, liquid and gas as the three states of matter. So if I have a diagram here, I can say this is solid, liquid and gas. Now what can occur is, if the particle moves from gas to liquid, we call it condensation. If it converts from solid to liquid, we call it this process as melting. If it convert the liquid to solid, we call it freezing. So if you put the water into the refrigerator, it will freeze into ice. So it converts from liquid state to solid state, and we call this process as freezing. However, there is a process when solid state directly changes into gaseous state, and this process is known as sublimation. So assuming that you have ice crystals and rather than becoming water, they directly evaporate, or you have kind of compounds like dry ice or something that directly evaporates. So that is the process which is known as sublimation. And then you have the gaseous phase that changes into solid phase directly, and this is known as deposition. So whatever water is evaporating from the ocean surface directly condenses and becomes clouds or forms ice crystals. So that is process is known as deposition. And finally, from liquid state to gaseous state, the most common conversion we say, when water is boiled, it evaporates. So liquid state changes into gaseous state, and this process is known as evaporation. So these are the 6 phases that helps you convert the various phases, that is from solid to liquid, liquid to gas and gas to solid. Now in this session, what is important is the two processes, that is sublimation and deposition. We would be focusing on these two, because what happens actually is, in case of dry ice, I can say dry carbon dioxide, what happens is it directly changes from solid state to gaseous state, and that evaporates, and you have cases where water vapor finally condenses into a solid form, and that forms the solid state. So you have the formation of ice crystals that takes place. So that is what is sublimation and deposition. Now next is condensation. What happens under the process of condensation is, the water vapor that is rising finally converts into moisture or solid form, and it tends to become kind of particles that finally become saturated and formation of clouds occur. So that is what is known as the process of condensation. The next important process, that is precipitation. Now precipitation or rainfall can occur in various ways. It can be in the form of rain, snow, sleet or hail. We have already talked about the various stages of precipitation in the previous class, where you can understand more about the various forms of precipitation. So what is important to note here is, how does precipitation occur? So you have numerous sources of water. You have lakes, ocean bodies, you have groundwater, and from all these sources you have water that evaporates up. And once the water evaporates up, it leads to formation of cloud, and that cloud again pour down in the form of rain. It can be in the form of rain, snow, sleet or hail, as we have discussed. So these all are known as various forms of precipitation. Now the most important thing to note is, of the total precipitation or the rainfall in simple terms, I can say, that is coming onto the earth, 74% of the precipitation directly goes to oceans, and only 26% of the precipitation goes to land surface. So most of the precipitation that is falling directly falls into the in the ocean surface, ocean bodies, and only 26% fall onto the land body. Now this is a very interesting topic that most of the students miss out in hydrological cycle, that is interception. What is actually interception? Consider there is a surface, there is a smooth surface. What would happen if I start pouring water from here? If I have a bucket and I start pouring water from here, it will roll towards till the end of the surface. That is a very smooth process of flow of water. But what would happen if on the same surface I have some obstructions? This water that I am trying to pour from this jug will go till here, and then it will find some obstruction, and only little of it will be able to percolate further or move further. So that is what is known as interception. Now interception is mainly due to the vegetation cover that occurs on the ground. Because of the vegetation or the plants that are on the ground, the water cannot smoothly move forward, and this is known as interception. However, from the plants and the grasses, what happens is there is evaporation that is occurring from the surface. However, there is evaporation in the form of transpiration that is occurring from the plants. The loss of water from the plants is known as transpiration. So this transpiration along with evaporation is known as evapotranspiration. That is another specific thing to understand, that hydrological cycle does not only involve evaporation, however it also involves the process of transpiration. And then there is the little ways that are left here from which the water will move forward, and this process would be known as interception. Now the next is percolation. What is percolation? Percolation is movement of the water towards the underground level, and when I say percolation occurs, it can be due to two phenomena. First is gravity, because there is a natural phenomena, the thing that is on the top will tend to go down by the law of gravitation. So first is the gravity that pulls the water down, and second is the capillary action. So under capillary action, what would happen? You have a tube here, and by the capillary movement the water would tend to move in the tube. So similarly, you have the two major actions, one is gravity and another is capillary, that leads to movement of water within the ground. This movement of water in the ground is known as infiltration. So water that is on the surface tends to go down, and this process is known as infiltration. Now when we talk about percolation, there are two things we need to understand. First is the zone of saturation. The zone of saturation is also known as the groundwater, and then above the zone of saturation you have the unsaturated zone or the zone of aeration, and this zone is technically known as Weddow's zone. The region, or I could say the dividing section between the unsaturated and the saturated zone is known as the water table. Now we have often heard people saying the water table keeps on fluctuating. During the summers, the water table goes down. That is the reason we are trying to explain here that this line which we are demarcating as water table shifts because of the changes in the level of saturated water and the unsaturated water. When we are trying to pull out water from the ground as a groundwater, we are trying to pull out the water that is present in the saturated zone, and the replenishment of this water takes much longer time than the amount we are pulling out. So that is very important to understand here. Now how can groundwater be utilized? So groundwater is mainly used or exploited for commercial and residential purposes nowadays. The role of tube wells have increased. Now the again important thing is artesian wells. Artesian wells drag out the groundwater to the surface. That is commonly seen in areas of Australia, and you have the returning of the groundwater to the surface level by the means of aquifers. So this is percolation. The next is infiltration. Infiltration is the amount of water that is trying to move into the soil. Now infiltration also depends on numerous parameters. If the soil is very porous, a lot of water will move down or infiltrate. So if I have kind of very porous soil which is with large molecules, this water will easily percolate. However, if there is a soil which is tightly packed, I can say for example clay soil, the water would find hard time moving down. So there would be less amount of infiltration if the soil is closely packed. However, if the soil is loosely packed, I can say for example sand, the infiltration would be much higher in sand as compared to clay. So that is important to understand the process of infiltration. So less infiltration occurs in non-porous soil, for example clay, and more infiltration occurs in porous soil. Again, the amount of vegetative cover governs the infiltration. So if there is a lot of vegetative cover, what would happen is the infiltration would be definitely the amount of water that is percolating down or being absorbed by the soil would be affected by it. The next process is runoff. That's the final process that we would be understanding. Now runoff is governed or is determined by numerous processes. When I talk about runoff, what is happening is you have the rainfall that is coming. Okay. Now this rainfall slowly and gradually moves on to the ocean. So what would happen if there is a steep slope, the runoff would be faster as compared to a flat slope. If there is a gentle slope, the runoff would be slower. However, if there is a steep slope, the runoff would be faster. So that is the first thing. So on the steep slopes you have faster runoff. Again, the type of soil that is present would govern the runoff, the water table and the permeability. So if the soil is more permeable, a lot of water will percolate down and the runoff would be less. However, the increase and the decrease in the ground level would lead to rise and fall of the water table and determine the amount of runoff. Next is vegetation, that would again affect the runoff. So if there is a lot of vegetation, the runoff would be slower. And finally you have the slope that we have already discussed. Now if in very simple terms I want to explain the hydrological cycle, I can explain it in this way. You have the melting that would lead to runoff, stream flow, and finally groundwater flow. From the ocean the water would evaporate. Here the condensation would occur. That would be the advection process, that would be the shifting process, and finally you have the rainfall. However, if I want to include the role of plants, then I would talk about the infiltration, the interception, the soil water storage and the recycling of this whole process. So that is very important to understand, or I could say the summary of what we have talked about. However, understanding the concept of hydrological cycle does not end here itself. It's very important to understand the reservoirs. So I can say there are three basic reservoirs, that is atmosphere, ocean and ground. So if we talk about here, you have atmosphere that is divided into two atmospheres, the continental atmosphere and maritime atmosphere. Then you have the land and the ocean. You have the amount of the various reservoirs and their capacity here and how the fluxes takes place. So you have the river runoff, then you have the evaporation from oceans, then maritime atmosphere you have precipitation. The same process occur here. However, on land along with evaporation, since there are a lot of plants, you have the process of transpiration as well. And movement from maritime atmosphere to continental would lead to the process of advection. So these are the common processes that occur. Now if we talk about in actual terms, we can say 97% of the total reservoirs are oceans. However, if we talk about atmosphere, it includes only 0.001% of the total reservoir capacity. And then you have a lot of reservoirs in the form of groundwater, lakes, soil moisture that is present in the on the land. So that's the remaining around 2 to 2.5%. Now next important concept to understand is residence time. So residence time can simply be explained as rate of replacement. So if we are using certain resource, in how much time that would be replenished back is known as residence time. So you have consider this box which has a capacity or amount of say 20. There is an influx of 5 and 5 and outflux of 10. Now what would be the residence time? If I want to calculate the residence time, I can say is the total capacity of the reservoir divided by the amount that is flowing in or out. We can use either. So you have, if I calculate in, it is 10, and if I calculate out, it is again 10. So since there is a equilibrium, it is known as a steady state equilibrium here, because you have a balance between the inflow and the outflow, and here the residence time would be say 2 years. Now this residence time varies from region to region. I can say for rivers it is usually 16 days. So in 16 days the water would be replenished back to normal. However, this residence time varies for everything, and for groundwater specifically the residence time is 100 to 200 for shallow and around 10,000 for deep. So on an average we say 1400 years. So 1400 years is an ample time for the groundwater to replenish back, or is the rate of replacement. However, the rate at which we are using the groundwater resources are much higher as compared to the residence time here. As a result, we say that groundwater may soon become, from a renewable source of energy, it can become a non-renewable source of energy. That means it might be possible that in future there are dry areas or dry zones which we mark it as blackout zones. Specifically in India you have the regions around Punjab and Haryana which are being marked as dry zones, where the groundwater table has gone down steeply. We would be covering this in respect to India in the separate sessions where we will be discussing geography of India. For now, we would be continuing with more topics related to climatology. You can subscribe to our channel for any further updates. Have a good day ahead.